Welcome to this Java Break with Basis. Today we conclude our three-part series of how Basis is investing in your application development. The first part introduced you to the production-ready business intelligence dashboard, and we looked at its features and functions. In part 2, we showed you how you could show it off to your management and or your customers. And in part 3, we're going to go down into the bowels of the stored procedure code and look and see how we can change it to work with your data. Let's look at our agenda. It's a very short agenda. We'll look at the code that we change so that we can point to our own production data. Then we'll discuss your choices of who controls access to the data. Is it BBJ or Pro5? And the good news is you have several choices. We'll look at additional resources that you can use to both implement this business intelligence digital dashboard, as well as leverage the power and feature and function of the extended edition of BBJ to really maximize the value of your investment in Basis technology. Then we'll take your questions. Well, let's look at some stats. This business intelligence digital dashboard that we've built has metrics tabs provided with 9 widgets on the sales metrics, 2 of which include drill downs, and there are 7 accounting widgets, also with 2 drill downs. All use stored procedures, 23 of them. 5 of them use SQL only, and 18 use read record syntax. So what do we need to change? We're going to look today at how we can just change the stored procedure code. It's after all business basic code, and any BBX programmer can do it. Our demos will use the Chili company database as if it's our production data set. Why have we chosen that? It's already included with the demos, and it has a different data structure from our production ready sample code. We're going to focus on just one simple widget today, and this stored procedure makes this work with your data. To recap on what a stored procedure is, let me hand off to Nick Decker to give you an explanation.
So what's a stored procedure, and why are they useful? In simple terms, a stored procedure, sometimes called an SPROC or SPROC, is a BBJ program whose purpose is to return data. Developers often use SPROCs to centralize data access logic and to simplify repetitive database queries. We can think of them as commonly used programs that extract portions of our data for use in our applications, Jasper reports, and dashboard widgets. SPROCs are flexible and support a variety of input and/or output runtime parameters. You can change these parameters each time you call the SPROC, so it's possible to write a general-purpose program that handles several cases, just like traditional BBX called programs. At its core, a BBJ SPROC is a standard BBJ program that ultimately returns a single value, or, more commonly, a result set. A result set is just a set of data rows. Think of it as a stripped-down table with only the records of interest. Because the SPROC is BBJ code, how you choose to gather the data and fill the result set is up to you. You can go wild with JDBC connections, SQL, and advanced Java data collections. But it's often much easier to simply reuse existing application code that opens a data file and reads the records to collect the data. The only point of interest is that you'll need to use object notation to get and set input and output parameters, as well as filling the in-memory record set. Since SPROCs are stored in a database's data dictionary, we can view our dashboard example database in the IDE's Enterprise Manager plugin and inspect its full-blown DD, defined with tables and procedures. But how would we make use of SPROCs when we don't already have a data dictionary? In that case, we could create an empty one to use as a container to hold our SPROCs. It's also possible to call a built-in SPROC from a system database. What do we mean by that? The Basis DBMS always comes with a special database called BBJ Sys, along with a few SPROCs that let you query data files and return an SQL result set. These built-in SPROCs create result sets from BBX data files or CSV files. All you provide is the location of the file and a string template that describes the record layout. There's even an advanced version where you can specify the field and record terminators of any text-based delimited data file. The system SPROCs are accessible to all databases, but even if you don't have a database defined, you can still connect to BBJ Sys and call a system SPROC without any need for a data dictionary. Once you do create a database in EM, you'll also have access to a few more SPROCs that deal with full text searches. Let's take a look at the first widget in our dashboard example, which creates a pie chart based on our top sales reps. The widget's SQL statement calls the SatoPrep PyAlt procedure, passing in parameters for the year and the firm ID. Let's view this in Enterprise Manager by opening our Databases tab and selecting the dashboard example. The Procedures tab displays all built-in and custom SPROCs for the database, and we can select the desired procedure to view its properties. Besides the general information, we get a listing of the parameters and the direction, in, out, or in and out. We can select the top right View Code link to take a quick look at the BBJ program that defines the SPROC. If we didn't already have the program written, we could have clicked on the Generate Sample Code template to have EM build boilerplate code based on the parameters list. Going back to the list of procedures, we're given sample syntax for calling the SPROC via SQL. We can copy the code and quickly test it in the SQL tab. After changing the parameter placeholders with real values, executing the query displays our result set. Okay, so now we've seen the SPROC definition in Enterprise Manager, and we've tested it. And we know that the dashboard widget transforms the result set into a pie chart. But how does the SPROC collect the data to build that result set? Our code starts by getting the input parameters and assigning them to program variables. It then defines the string template for the returned result set and creates the in-memory record set. After that, it opens the salesperson and sales analysis data files, then reads in the records based on the sales figures for each sales rep, given their firm ID and year. Remember those? They're our input parameters. We write each sales rep to the record set along with their total sales. After processing all the records, the program sets the return result set and exits. This SPROC is straightforward, but it provides useful insight into our sales team's performance, which we can leverage in dashboard widgets and Jasper reports.
Thanks, Nick. So, we're going to be converting the stored procedure to use your data. We're going to start with this pie chart showing sales by salesperson. Without further ado, let me hand you off to Kurt Williams to take you through the salient steps of modifying the code.
In the last segment, we saw a very good explanation of what an SPROC is and what it can do. All the SPROCs and dashboard widgets in the dashboard example are nice to look at, but wouldn't it be great if we could convert them to query your data and present it on the dashboard? The specific SPROC we saw was called SatoPrep PyAlt, which provides data for this pie chart. In the dashboard example application, all of the SPROCs are located in the SPROC subdirectory. The code is well remarked for clarity and to help guide your developers in converting to use your data. As you can see here, there are remarks setting off each section of code. Here we have the section that declares the BBJ stored procedure data object, which delivers the input parameters to the procedure and in the end delivers the result set to the caller. We get input parameters here. We set paths to the programs and data files here. We open files here. And we execute the loop, which builds the sales by salesperson data for presentation in the pie chart at this point. All of these are clearly delineated and easy to follow. In this Java break, we're going to take that SPROC and widget we saw in the first segment and convert it to present data from another company which has data files that are organized in a way that differs from the dashboard examples database. We're going to use the Chili Company data as a stand-in for your data. The first step is to change the path to the data files so that it points to the Chili Company files instead. The original SPROC points to the dashboard example data files here. In the modified SPROC, we have changed it to point to the Chili Company data files instead. The next step is to open the data files that we will need to gather the correct data. In the dashboard example database, we only needed to refer to two files, the sales rep table and the sales analysis by salesperson data. In the Chili Company, there is no sales analysis table, so we will need to rely on sales data from the invoice table. It is also complicated by the fact that the salesperson is not recorded in the invoice table, which requires the program to look up the customer to find the sales rep that gets credit for the sale. In the modified program, we open the invoice, customer, and sales rep files in the same way we opened the data files in the originals. Here, here, and here. Also, in the original program, we had a string template definition library. In the modified program, we'll simply dim the string templates immediately after the file open. Here, here, and here. There are two input parameters in the original SPROC, year and firm ID. In the Chili Company database, there is no distinction between firms. There is only one. The firm ID parameter is now meaningless. Rather than changing the input parameters defined for the SPROC, we will simply ignore the value passed in. In this section, where the program retrieves the parameters from the BBJ stored procedure data object, we have remmed out the line that retrieves the firm ID. Long-term and for a more final solution, we will want to change the input parameter definition to eliminate the firm ID. There are three more sections of code that need to be reviewed and modified a bit. The loop that reads the sales data from the invoice table for the given period and summarizes it for use in the result set will need some modification. The subroutine that handles the change in salesperson and the loop that builds the result set to be handed off to the BBJ stored procedure data object both need careful review and modification. In the original SPROC, the sales analysis table was keyed on firm, year, salesperson, product type, and item number. In the Chili Company database, we're relying on the invoice table, and the key chain is based on invoice date and invoice number. In the original, we positioned the key pointer by reading with the firm ID and the year, as you can see here. In the modified program, we positioned the key pointer by reading with the January 1 date of the year passed in, as you can see here. This difference in key change drives the changes in the way we decide to exit the loop. In the original, we exit when we have a record that has a year greater than the year we are reporting on. Here. In the modified program, we exit the loop when we encounter an invoice date that is greater than the 12/31 of the year we are reporting on. Here. The final change is in summarizing the sales total. In the original, there are 12 monthly buckets in the record, which must be added together. That's what's taking place here. In the modified Chili Company program, there is only the total amount from the invoice table to be added. The addition of the 12 monthly buckets is remmed out, and it's picking up only the total amount from the invoice table here. In the salesperson break subroutine, there's only one change needed. That is in the way we initialize the salesperson code field for use in identifying when the salesperson changes. In the original, it is the sales rep, sales analysis salesperson code, and in the modified program, that value is coming from the customer table, customer.salesperson. Here in the original, and here in the modified program. The final change needed is in the loop that builds the result set for return to the caller. In the original, the salesperson's name field was code description, and in the modified, it is simply name. Here it is in the original, and here it is in the modified. There is no change needed in the way the result set is returned. We simply provide the result set object to the stored procedure data object for return to the caller. Right there. The final step is to test the modified SPROC in the Enterprise Manager. It should run without error, and it should return the result set we are expecting. We check the list of SPROCs by selecting the Dashboard Example Database and clicking on the Procedures tab. We'll browse the list until we see the Sado Prep Pi Alt SPROC, and then click in the Sample as SQL column to get the SQL call template. We'll copy it out and then bring up a SQL panel on the dashboard example database. And paste the copied SQL into that panel. The next step is to change the placeholders with the actual parameters that we want to use. The Chili Company database is somewhat out of date, but we will be searching for the year 1993. We're ignoring the firm ID, but we still need to pass it. We'll make it into an empty string. We can execute the query by clicking the running man icon and execute it. All looks good. We have a result set with 6 rows and all of the totals that we're looking for. The program, dashboardexample.src, is located in the prog subdirectory and is the program that builds the dashboard categories, and each individual widget. There are 17 different widgets displayed on the dashboard example project. Working and modifying each one of them, it can be useful to branch around the other widgets that you are not working on. There is a line label at the end of the program called skip remainder, as you can see here. We can then place a go to skip remainder following the section of code that creates the sales by sales rep widget and bypass the balance of the other widgets, which is here at the end of the section of code that creates the sales by rep pie chart. We can now run the dashboard and see our new results. In the original chart, based on the dashboard example database, we had 3 salespersons displayed, and in this modified one with the new data from the Chili Company, we have 6 salespersons shown. Modifying the SPROCs and the program that creates the dashboard is straightforward and can be done with read record or with SQL selects. It makes presenting the company's data in an easy to understand and act on form simple.
Thanks, Kurt. What if you want a data dictionary and you don't have one? Well, it's pretty simple. We've got tools to help you with that. You can create a data dictionary for any basis data file. Your starting point is to convert your IO list to a string template if you don't already have one. Use Enterprise Manager to define the table. So the data file will determine the keys, and the string template will automatically populate the columns. And then you can test an SQL statement to make sure it's all working properly, using something like select star from the table name. So this is what the new table wizard looks like. Put in your table name, point it to the data file that you want to use, and check the radio button to create the table definition for the existing data file. Then you'll be prompted for the string template, which you can cut and paste, and that'll populate the column definitions. And finally, you can rename any of the indexes that it's generated for you automatically from examining the physical file on disk. And you can test your resultant data dictionary entry by doing something like select star from customer and seeing the contents of your data set. And if we'd built all of the data dictionary definitions for all the tables, we could have done without any of that read record code and used a complex SQL select statement to get all the data we wanted very simply in this fashion. For those of you who haven't moved to the BBJ database, you may question who controls the data, BBJ or Pro5? Well, the good news is you have several options. The best by far is to use BBJ. If you're running Pro5, you can continue to run Pro5 interpreters, but point Pro5 to use the memory mapped file protocol. That is our recommendation. If you want, however, to continue to run Pro5 and have Pro5 control access to the data, you can use the Pro5 data server from the BBJ interpreters. However, the simplest way is to turn off exclusive file access from BBJ and use the shared file access. In other words, BBJ will use the same locking mechanisms as Pro5. No data server required. One caveat, though, is that all BBJ interpreter sessions will be treated as if they're a single user when accessing the data. The memory map file protocol is a mechanism for Pro5 applications to swap out the Pro5 file system with the BBJ file system, the basis DBMS. There's no TCP/IP networking overhead required. There's no code change required to your application code whatsoever. and no data conversion required. How do we do that? Very simply, in Pro5, enable the data server via the config.bbx using the setops verb, and then also set this STBL value, bang ds open. That'll tell the Pro5 interpreters to use the BBJ data server. In Visual Pro5, it's far easier. Simply switch from the Pro5 data server to the BBJ Pro5 data server. In both cases, you'll need to enable the Pro5 Data Server 5.0 within BBJ's configuration. From Enterprise Manager, you can go across to the file system and the Pro5 data server and set Run Server to true. And if you're running on Visual Pro5 and you're already using the Pro5 data server, an even simpler change for you is to stop the Pro5 data server and simply use the same port number as Visual Pro5 is already listening in on. What about performance? One of the major benefits of using the BBJ database management system is that concurrent read performance far outstrips Pro5's performance. The green line here represents the scalability of the BBJ database management system, whereas the blue line, as more concurrent users are accessing the same data file, there's actually a slight degradation in performance. And of course, there are many features and functions that suddenly become unlocked once you move across. Over 15 years worth of improvements. Full text search engine Lucene is available to you. The SQL engine, database replication, triggers, asynchronous triggers, change audit logging, and even online copy jobs, just to name a few. So what about additional resources? Well, we've got a host of additional resources. I'd reference you to the YouTube video after the fact if you want to get these links. But there are many Advantage articles that talk about various aspects about the dashboard utility, as well as talk about the memory map file protocol capabilities. And we have YouTube Java Break videos that also looked in particular at the dashboard capabilities and the new widget wizard to automatically generate widgets without any code. And finally, we have an IDE user group wiki, which has a dashboard section with tutorials and sample code that you may find useful. Some other resources, here are a couple of screenshots showing the graphical diff of the changes that Kurt brought about to that store procedure early on. There are 4 graphical diff screens here that you may again wish to refer to after today's Java Break is viewed. Pretty simple changes, as I'm sure you'll agree. So in summary, what have we covered today? We looked at how to change the code to point at your own data and make it production ready. We spoke about how you can decide who should control the data, BBJ or Pro5. And then we listed a whole host of additional resources to get you productive in no time at all. Let's take your questions.